This is the best use of Clausen integral function. Okay, so we have this integral from 0 to pi by 4 of x cot x dx. And let me just introduce Clausen integral function just in case if you don't know about that. Okay, the CL2 of x, this is defined as an infinite sum. Sum from n equals to 1 to infinity of sine nx by n square. And if you try to use the complex numbers to sum this up, you also get an integral representation for this, which is the following. Integral from 0 to x, yes, and then minus ln of 2 sine t by 2 dt. Okay, so these two are basically the definitions. One of them is integral definition and other is sum definition of the Clausen integral function. Yeah, and this is actually a special case of the general Clausen function where the base is m and it's defined as two different sums depending on either m is even or odd. Okay, now let's do it. So first of all, let us try to simplify this cot x by using integration by parts, and also this x gets simplified. So let me do that. X and the integral of cot x is ln of sine x, yes, and this goes from 0 to pi by 4 minus integral from 0 to pi by 4. Derivative of x is 1 and the integral of cot x is just ln of sine x dx, yes. And now next is at pi by 4, this is just pi by 4 times ln of sine pi by 4 is ln of 1 by root 2, yes, and then minus at 0 ln of sine 0. So but here is 0 times ln of sine 0, and if we this is 0 times infinity, but we have to take limit and it goes to 0. Okay, minus and then we have integral from 0 to pi by 4 of ln sine x dx. Okay, good. Now over here I can write this as I can first of all take a minus sign in the inverse it, and again the power 1 by 2 can be taken outside. This is minus pi by 8 ln 2. And over here I will try to make this sine x by 2 just to take it in this form so that I can use the Clausen function. So what I can do is I can make a substitution. Let's say u is equals to x by 2. Sorry, u by 2 is equals to x. And then if I make the substitution, u equals to x, so this will be integral from 0 to pi by 2 of ln of sine of x is u by 2, yes, and dx will be du by 2. Good. Now I can take 1 by 2 out. So this is minus pi by 8 ln 2 minus 1 by 2 integral from 0 to pi by 2 of ln of sine u by 2 du. Good. Now again what I want to do is also make this 2 sine u by 2, yes. So let me add in plus 2 and then minus ln of 2, yeah, and so this becomes minus pi by 8 ln 2 minus 1 by 2 of integral from 0 to pi by 2 ln 2 sine u by 2 du, and then plus 1 by 2 integral from 0 to pi by 2 of ln 2 du, yes, that is perfectly fine. Now this can be integrated. Okay, so minus pi by 8 ln 2, and this, if I take just half and I take the minus sign inside, this minus ln of 2 sine u by du, this is just the antiderivative of the Clausen function, and we have 0 to pi by 2, so this is just Clausen integral function of pi by 2, yes, plus now this is 1 by 2 and ln 2 times pi by 2. Okay, looks good. Next is to evaluate this. Now to evaluate this, we will use the sum definition of the Clausen function. Pi by 8 ln 2, pi by 8 ln 2, and then half of sum definition is sum from n equals to 0 to infinity. Now sine of nx, so pi by 2 times n by n square, and this is plus pi by 4 ln 2, yes, good. Now The pi by 4 ln2 and minus pi by 8 ln2, they add up to get a pi by 8 ln2. And over here we have to notice how the sign pi by 2 n changes. This for like let's say 1, if n is 1, that will just be 1. When n is 3, that will be minus 1 sine of pi by 2 n. At 2, that is just 0. At 4, that is just 0. At 5, that is again 1. Yes. At 6, that is 0. So how do we like write this sum? So at 1, this will be 1, 3 minus 1, 5, 1. Yes. So let's say sum from n equals to 0 to infinity. We have no, not from 0, let's say from 1. From 1 to infinity, and we have just odd numbers over here. Yes, only for odd numbers this sum actually becomes some number, yeah, for even though it goes to 0. Now for only for odd numbers we can take this sum, and also for odd numbers, for the first one, n equals to 1, this will just be positive number. Yes, so let me give it 1 n plus 1, so that when it's 1 it's become 2, so a positive 1 will be there. When it's 2, it's 3, so negative 1 will be there. Yeah, good. Okay, yeah, now if we look at the sum, this is just 1 by 1 square and then minus 1 by 3 square. Yeah, it looks good. Yeah, completely fine. Now okay, so we have this. Now to evaluate this, this is just the g constant. I guess it's Catalan's constant, I'm not sure. Okay, just but we know that it's actually a Catalan's constant. And if we evaluate this, this is just 1 by 1 square minus 1 by 3 square, this 1 by 5 square. Yes, we don't really have a closed form for this, and we denote this sum by g. We know its value, but not really a good closed form. Okay, so we get pi by 8 ln2 plus this is just g by 2. Yes, now I can take 1 by 8 common. If I take 1 by 8 common, we get pi ln2 plus 4g. Yes, and that is our answer. This is our answer. We have finally solved the question. Yes, by 1 by 8 common, pi ln2 plus 4g, and that is the answer. The flow was, first of all, we use integration by parts, and then we try to change it to the form of form of the Clausen integral function, and then we use the Clausen integral function, and then we used its sum representation, and from there we got the value. So that was it. It wasn't too hard. I hope you enjoyed the integral. Hope it was a nice time solving it. Thanks for watching, and look forward to seeing in the upcoming videos too.